So we're going to be taking a look here at how to write an exponential function when we're given just a couple of the points that it goes through. As we do so, this method that I'm going to be using here, I like this particular method because it doesn't depend on this having been an exponential equation. This isn't some method that only works in this scenario. It's actually something you could use in a multitude of different situations. Basically, we have 2 points and we're looking for 2 variables. And so what I'm going to do then is I'm actually going to take each of those points and plug them into the equation for the x's and y's and see what that looks like. So for the first one then, that means that instead of f of x, remember that's the same as y, so I go 6 equals, that's my y coordinate and my point, c times a to the power of 1. It's c and a that I don't know, and it's x and y that I do know. Now, I'm going to go ahead and simplify that just a little bit, because a to the power of 1 equals a. So I'm going to write that then as 6 equals ca. I'm going to do the same basic thing for the other point as well. So here it's going to be 2/9 equals ca to the power of -2. And again, I can simplify that on the right side. So on the left, it's still the 2/9, but it now equals, okay, the negative exponent. The negative exponent, remember that, flips it in the fraction, right? Now, what is the -2 actually attached to here? The a, and only the a, which means the c is still on the top. Only the a flips into the bottom. And so that's going to be a squared on the bottom here. So we got 2/9 equals c over a squared. Now, having 2 different equations with 2 different variables, we then can combine them in order to figure out what any one of those variables is. And there's a few different ways, like there's substitution, so like I could figure out what either c or a was, and I could take that value and plug it into the other equation, but that has the potential for getting pretty ugly depending on what we're dealing with. I actually prefer something that's actually more just setting them equal to each other. And so what I'm going to do is I'm going to end up with both of these equations to be c equals, and if they're both set equal to c, they'll be equal to each other. So let's do that then. So for the one on the left here, 6 equals ca. If I want to get it to be c by itself, I'm going to divide both sides by a. Then, having done that, we got 6 over a equals c. We can repeat the same process on the one on the right side here. So I got 2/9 equals c over a squared. How do I make that into c equals? Yeah, I would multiply by a squared. A few of you will force the cross multiplication onto it, and that will work, but it will just give you an extra step here. Either way you do it, though, you should end up with 2a squared over 9 equals c at that point. So we now have 2 equations that are set equal to c. Well, if they both equal c, they must equal each other. So I now set those 2 equal to each other. So it goes 6 over a equals 2a squared over 9. Now solve that equation. All right, so I would now cross multiply to finish solving this out. So I'll do 6 times 9, which gives me 54, equals a times 2a squared, so that will give me 2a cubed. Divide both sides by 2, so now 27 equals a cubed. And then we take the cube root of both sides. Cube root of 27 is 3. So we got 3 equals a. All right, so we know that a equals 3. Knowing that, I can now go find c, because notice I got a couple different equations here that I could use to find out what c equals. I want to use the simplest of those for this next step, so I'm going to go ahead and use this one. I know c equals 6 over a. So I'm going to plug it in there. C equals 6 over, and now I know what a is. A is 3. So if c equals 6 over 3, c equals 2, which then means I have my final answer. I was asked to write the equation. Here we go. F of x equals c, which is 2, times a, which is 3, to the power of x. And again, remember why I chose this method. This method, notice, was not specific to this having to be an exponential. It was that there were two unknowns and we had 2 points. So I could just plug it in and logic out how might I get from point A to point B. So you can apply this method to a number of different situations along the way. But today our focus is on these exponentials, and so we're going to do a couple more with these exponentials just to make sure we have the ideas down. So please write down and do this problem, where you are going to be doing it this time from the graph, but otherwise the same idea. Now this time, of course, we're given a graph, but really, isn't it still just 2 points? They just happen to be drawn onto the graph. So we approach it the same way. So start by plugging the first point into our general equation. That gives us 3 equals CA to the negative 1. And remember, clean that up before you go too far, that A to the negative 1. Make that 1 over A, or in this case, C over A. Then we repeat that same process for the second one, and we end up with 4/3 equals just CA, because the A to the 1 just equals A. Now for each of these, just like we did last time, you solve them each to be C equals. And although technically you could try to make it A equals as well, yes, that could work, but C equals is going to be a little easier. And so for the first one then, the leftmost one, at least in the way I've drawn it, I'm going to multiply both sides by A. So that gives me 3A equals C. And on the second one, I'm going to divide both sides by A because I'm again trying to leave that C behind. Now every now and then I see sometimes people get a little bit tripped up on dividing by the A when we have that fraction on the left hand side. If that's getting you tripped up, remember that dividing by A is exactly the same as multiplying by its reciprocal. So dividing by A is the same as multiplying by 1 over A. Hence why the A goes in the bottom of the fraction. And now that we got them both to be C equals, we set them equal to each other. So we're going to have 3A equals 4 over 3A. And we solve from there. And at this point, though, I do want to point out there's 2 different ways you progress from here, just depending on personal preference. Some of you will say, I'm going to multiply both sides by this 3A because I can multiply by the denominator. That works. The other way you might be thinking about it is you would say, oh, well, I can make that 3A over 1 and I can cross multiply. That also works. Whichever way you did it, though, your next line will look exactly the same. It'll be 9A squared equals 4. And then we continue solving it for A, so we divide both sides by 9, so that gives us A squared equals 4/9. And then we take the square root of both sides, so A equals the square root of 4/9. And then we take the square root of our fraction. And the square root of a fraction, that just means take the square root of the top and the square root of the bottom separately. So square root of 4 is 2, square root of 9 is 3. So we have our A. Now, before I go too far, I want to answer a nagging question that some of you are having. And that is, wait, we just did the square root of both sides of the equation. Whenever we do that, we need to remember to include plus or minus. Where's the plus or minus? We actually purposely left it out here. The reason is because this work that we're doing down here, it's not just abstract algebra. This is not just algebra out of context where we don't know what's going on. We actually know what it represents. And in this case, we're finding the A value, which represents that base of our exponential. The base of the exponential has to actually be positive. And because the base of the exponential has to be positive, it means we can ignore that negative case. So I'm just skipping over that negative here. And then, now that I know what A is, I can find C. So, do just like we did before, we're going to go into one of those equations. I like this one here, the 3A equals C. And so I'm going to go 3 times the 2/3 equals C, which means that C equals 2. Now that I know what A and C are, I got my final equation. So f of x equals C, which is 2, times A, which is 2/3, to the power of x. And you'll notice here we ended up with an a value that was a fraction, that was less than 1. Did you see that coming? Do you see how you could have seen it coming? Because notice what our graph is doing, because we can actually see it. And so we can actually kind of see it coming in this case. Our graph is an example of exponential decay. It's getting smaller with time. That means that our base here has to be a number that is between 0 and 1. Because if that number there was bigger than 1, it'd be exponential growth. We'd be getting bigger as we increased our x values. So one way that you can kind of see it coming and check to make sure that you're getting a reasonable answer as you go. I think you're pretty good at these, but we want to practice one last time. Go ahead and work through the whole problem here, start to finish, and then we'll check that final answer when all is said and done. And there we have our final answer. Should find that f of x equals 5 times 2 to the power of x. Now moving into a different context, we're going to take a look at a few other problems here, starting with this one. Now I chose this particular equation because this is an equation you're well familiar with. It's one you've dealt with many times before. It's one that you can actually picture the graph of very easily because you've used it so much. So it's going to help us to see whether we go from equation or graph or even table, that all these rules work the same. So first question that we need to ask ourselves here is it a function? Is it a function? Yes, it is. Now, how do we know that? Again, it does go back to being able to visualize the graph as one way to do it. Because if I'm actually visualizing what does the graph of this equation look like, I know it's going to be a parabola, looking something like that. And if I want to know if it's a function, that means there can be no more than one y for any given x, which is often a confusing way to say it. Oftentimes we just remember it by remembering that we do what test? The vertical line test. And the reason why the vertical line test works is because the vertical line is looking to see how many y values there are for that given x. All right, but now the next question here. Is this an example of a one-to-one function? No, it is not. It is not a one-to-one function. And for knowing if it's a one-to-one function, in addition to it being a function, there can also be no more than one x for any given y. Or what do we call that test? The horizontal line test, yeah. So basically, in order for it to be a function, it only has to pass the vertical line test. For it to be a one-to-one function, it has to pass both the horizontal and vertical line test. The whole idea being that in a one-to-one function, there's no repeated values amongst the x's or among the y's. So nothing gets repeated along the way in any way, shape, or form. One of the nice things about one-to-one functions is that we do a lot more work with their inverses. Now, this one may not be one-to-one, but we're still going to find the inverse of it because we could use a little bit of that practice along the way and to remember how do we do the inverse. So please write down that equation and do the work to find the equation of the inverse. And as you're taking a look at it, if you're sitting there staring at it, like, how would I go about that? Remember the basic idea of an inverse? The fundamental idea of an inverse is that you switch x and y. And so wherever there was an x, there's now going to be a y. Wherever there was a y, or in this case f of x, there will now be an x. And so the first thing I do to find this is I'm going to go x equals y minus 5 squared plus 9. And then you're going to solve that equation for y. Make it y equals. And so we end up taking the square root of both sides. And when we do that, we need to remember to include plus or minus. So So make sure you include that plus or minus in front of the square root. And then we just have one last step to get the y by itself. I'm going to add that 5 to both sides. If you choose to write the left-hand side, or it might have been right-hand side on your paper, as 5 plus or minus the square root, that's perfectly fine. I chose to write it as plus or minus square root plus 5. Now, there's just one little detail though that I'd like to tweak about this, because you notice that in our original equation up there, it wasn't actually y equals. It was f of x equals. And because the original was f of x equals, I don't want to leave my answer as y, because our original equation didn't have a y in it. So I want to tweak that just a little bit. What am I going to write instead of y? It won't be f of x, it will be the inverse of f of x.